In this clip, we see Flipper in a car not wearing a seatbelt nor have a headrest, and according to Newton's first law, when this car crashes, Flipper will want to continue to stay in motion at the same speed due to inertia. Because of these safety features, the seatbelt and the headrest, Flipper will have restricted motion and will remain in the car. Even though Flipper will want to continue in motion because of Newton's first law, the seatbelt will stop his motion and the headrest will cushion his backward force. In this clip, items are placed in the car where they shouldn't be placed. As you can see, the objects, due to their location, fly out of the car. This is because of Newton's first law, for the objects in the car are traveling at the same speed and in the same direction as the car. And because inertia is acting on these objects, they want to stay in motion, causing them to fall off. In this clip, items are placed in the car where it is safe. The pocket they are in absorbs the force of the crash and allows the items to stay where they are.
When the driver slams on the brakes, thinking that will prevent from skidding and crashing, they are actually allowing the car to continue at the same speed and skid on the road. This is because of inertia and the lack of friction from the road to the tires. The same effect takes place when hydroplaning as well. The car crashes into another and eventually skids to a stop in the middle of the highway. When a car crashes into the guardrail, it bounces off instead of just rolling into the other lane, preventing extensive damage.
To show the effect of the force when a car crashes into a wall, there will be four situations, with two different masses and two different speeds. The mass of car 1 is 2,730 kilograms. The mass of car 2 is 1,164 kilograms. Speed A is 27.8 meters per second, and speed B is 41.7 meters per second.
Car 1's force comes out to be 73,114 newtons. Car 2's force comes out to be 32,359 newtons. Car 1 has a larger force because it has a larger mass. In the third and fourth situations, Car 2 with a speed of 27.8 meters per second had a force of 32,359 newtons, and with a speed of 41.7 meters per second, the force was 48,538 newtons. The fourth situation resulted in a larger force because it had greater speed, thus a greater acceleration.
How not to drive a car.